Once again, welcome to ITSE 2309. Today we'll be talking about Chapter 4, Entity Relationship Modeling. I'd like to go back and pick up on an example I've been using before, and that has to do with the architect and the bathtub, and how I mentioned that, you know, if you see a bathtub, there's an implied process of infrastructure support, which would be the water supply and hot and cold water, and the wastewater side, the draining. I mean, so just the fact that you see the picture, there's an implied infrastructure mechanism to support that idea. Now, in this chapter, what we're going to do is we're going to graphically represent how data flows through a model. Just like plumbing and water flows downhill, there is an implied process on how data flows through a database system. Now, we had talked about the graphical representation and the models that are used. So there is a Chen model, there is the Crowfoot model, and there is the UML model. So there are three different models. And the distinction is that some of those models are theoretical in application, more conceptual. Some of them are more, what's the word I'm looking for? Implementation. So, you know, you can draw it, which is separate from building it. So in this process of graphical representation, the different models that are used to signify how conceptualization would happen, separate and apart by the actual physical building of it. And then once it is built, the final physical representation was going to happen. So the reason there are these different models is because they actually represent the idea, the putting the idea on paper, and then actually the final product. And usually, you know, if you have when you build a house, you're building it and you say, well, you're going to paint the counter, but you don't know what the counter or what the walls are going to be. So there's the idea that, yes, we're going to paint the wall. Well, you know, what color are you going to paint the wall? So there's this evolution process that evolves. Now, as in any process, when you're going to begin with new ideas, once again, this chapter will have new terms, definitions, concepts. So to deal with the idea of terms, definition, and concept, we'll be using entities, we're using attributes, we'll be introducing domains, and we'll be using identifiers. So you have four general concepts that will be used to explain the process that we are doing. Also understand that in this itemization item, there could be a one-to-one relationship, a one-to-many relationship, a many-to-many relationship. So you have to graphically identify these processes. So you have to identify whether there's going to be a singular event or a plural event, which would help you understand how things are going. As in any graphical representation, there is a tendency to use symbols. Now, just as, you know, when you see a tub drawn on a piece of paper, you know what a tub is, and you know what electrical outlet is. When you're starting to do data flows, the Chen model, the Crowfoot model, and the UML have unique identifiers. So the Chen model uses the oval, uses the diamond, and uses a rectangle. The Crowfoot tends to center around the box or the rectangle, and this is where you have the primary key and the data that supports. And then you have the UML process. Now, the Chen diagram is more of the idea type thing. This is where you're going to draft it out, and this is what you want to do. The crow's foot is more of what it's going to look like when it gets through. And then this would be the actual product. So you go from the idea of what I want to do, this is how I'm going to do it, and then this is what it's going to look like when I get through. After you finish, this is the final product. Now, just as in the plumbing scenario, water goes downhill, the idea is how do you graphically represent how data will flow through this process? Well, they use different graphical representations. There is the use of the solid line, which has a unique concept. You have the dashed line that has a unique concept. And you also have the idea of the chevrons. Now, these items are designed to give you an idea. So if you see a piece of paper and you see this, you know which way things are happening. You know where data starts, where data goes. Now, understanding that we are talking about relational databases. So all this stuff also signifies not only the way data flows, but it also recognizes, signifies how the data is related as it is flowing together. There's also the idea that sometimes, pictures do not give enough information. So there's also the introduction of one-to-many, one-to-one, or many-to-many scenario to help get the idea across of how information flows. Also, there's a lot of text involved. So there is also the use of text. So on the line, they'll add text. So sometimes you see generates. So there is the line, the chevron, with text, with numbers. All these items are used to help get the idea across of what's happening in the database. Now, the textbook uses several examples. The two that are used, actually there's three used. There's one about a car. For example, they have where a car, so this would be the car, can have a VIN number, a car can have a year, a car can have a model number, and a car can have a color. Now understand that on the color, you can have many types of color. A car can only have one VIN. A car can only have 1 year. A car can only have one model. But a car can have many colors. So in this process, how do you signify that there's only one VIN, that there's only 1 year, only one model, but there are many colors that car can come in? So you have to help with these lines. So the lines will tell you that there's a one-to-one, one-to-many scenario. The other one that is used extensively in this item is the idea of a school. And this is where it gets a little bit more complicated in that they use the idea of a professor and a class. Okay, so you have a professor and a class. Now there's a lot of activity that happens that before a professor can have a class, you have to have students. Okay, now before the student can go to the class, he has to enroll. So even though, remember I told you about the implied infrastructure where you have the tub and water has to flow downhill? Well, as you're drawing this stuff, if a student's going to be in class, he has to enroll. So that implied infrastructure to support the methodology is the idea that as you're drawing this thing out, you have to kind of superimpose the idea that in order for the class to exist, the student has to enroll. That's a separate activity that allows the other activities to unite. As you progress through this process, you can also limit some of the activities. For example, how many classes typically does a student have the ability to enroll into? 1 to 4. So as you're doing this, what you can do is you can say that a student can have 1 to 4. Actually 0 to 4. The problem is 0, is he a student? So you would have that in order a student can have 1 to 4 classes that he can take. Now the professor could teach one too many classes. However, the professor can only teach one class at a time. So as you're drawing this stuff out, the symbolism that's used is used to indicate that yes, a professor can teach many classes. However, the professor can only teach one class at a time. The student can take many classes. However, he can only take one class at a time, but he cannot take more than 4 classes. So the symbolism and the tech support is used to help get the idea across that yes, data is flowing, but there are conditions to the way the data is going to flow. So once again, a professor can teach many classes, but he can only teach one class at a time. So how do you graphically indicate that yes, he can teach many classes, but only one at a time? And then on the student side, yes, a student can take many classes, but there's a maximum of 4. So this is what this chapter talks about. It talks about entity relationships, modeling the relationship, putting identifiers on how data flows to help the person who's reading the graphical representation understand that, once again, the professor can teach many classes, but he can only teach one at a time. The student can take 4 classes, max, but he cannot take 4 at the same time. So these are the conditions that have to be superimposed. And then the other scenario is that in order for a student to take a class, he has to enroll. So as you're drawing this stuff out, you have to put on there the activity that must occur for the action to exist. So before a student can take a class, he has to enroll. And then you have an intermediate step. So this would be the enroll. This would be like the student, this would be the enroll, and this would be the class. So this is the action that has to occur before the student can enroll, which is the activity of that underlying structure that has to be there for the activity to exist. And so we're talking about the ER diagram. We're talking about the conceptualization of the idea. You're talking about what it's going to look like and what it actually looks like. So this is the idea. This is what you plan to do, and then the UML is what actually you wound up with, because there's always adjustments and tweaking, all kinds of stuff. So you go from the idea, the plan, and the actual event. And that concludes chapter 4.